When adding 4 receptacles in a bedroom and running a 12-2-2 Romex cable from the basement to junction box in the attic, then using 1/2-inch electrical metallic tubing, commonly called EMT, across the attic floor to 4 junction boxes above the bedroom wall, you will need to run number 12 American wire gauge or AWG-THHN wire inside the EMT conduit with a green, black, and white wire to each of the 4 receptacles in parallel. The question is, firstly, do you need to derate the circuit in this configuration? And secondly, can you use a 20 amp arc fault circuit interrupter or AFCI breaker? Also, if in the future you use the second half of the 12-2-2 cable and run another white and black conductor in the 1/2-inch EMT, will you have to derate? For the initial configuration of 1 black, 1 white, and 1 ground wire, no, you do not need to derate the circuit. You can use a 20 amp AFCI breaker. However, if you run another white and black conductor in the 1/2-inch EMT, you will need to derate the circuit to 80% of its ampacity. This is because for current carrying conductors in the EMT, the conduit is considered fully enclosed per National Electrical Code or NEC tables. For a 20 amp circuit, derating to 80% would result in a maximum overcurrent protection of 16 amps. It is important to note that using 3/4-inch EMT would not fix this derating problem. The derating is due to the number of current carrying conductors in the EMT, not the diameter of the EMT. It is a good idea to have spare conductors for future use, such as running the 12-2-2 Romex cable. However, it is not recommended to use 12-3 cable to get to the attic and then use a double pole breaker for a dedicated line. AFCIs are designed to protect against arc faults, and using a double pole breaker could bypass the AFCI protection. It is better to use a dedicated circuit with a single pole AFCI breaker and separate conductors for the neutral, hot, and ground wires. To avoid derating while still providing the desired functionality, consider the following revised plan. 1. Run 12-2-2 Romex from the basement to the attic junction box. 2. From the attic junction box, run 1/2-inch EMT to each of the 4 junction boxes in the bedroom. 3. In the EMT, run THHN number 12 conductors, black, white, and green. 4. Connect each of the 4 junction boxes or receptacles in parallel. 5. Use a 20 amp AFCI breaker. This plan will provide the desired functionality without the need for derating. When installing electrical wiring, it is important to follow the National Electrical Code or NEC and local codes to ensure safety and compliance. The NEC provides guidelines for the proper selection and installation of conductors, conduit, and overcurrent protection devices. It is important to consult the NEC for specific requirements related to your installation. Some important considerations when working with electrical wiring include ensuring that all conductors are properly sized for the intended load, using the correct type of conduit for the application, properly grounding all equipment, and using appropriate overcurrent protection devices such as circuit breakers or fuses. It is also important to use proper wiring techniques to ensure that all connections are secure and that there are no exposed wires. When working with the EMT conduit, it is important to use the correct fittings and connectors to ensure that the conduit is properly grounded. EMT conduit is typically grounded through the metal raceway, which provides a low impedance path for fault current to flow back to the source. It is important to ensure that all EMT fittings and connectors are properly tightened to maintain a good electrical connection. When running conductors in EMT conduit, it is important to avoid exceeding the maximum allowable fill rate. The NEC specifies the maximum number of conductors that can be installed in a given size of conduit. Exceeding the maximum fill rate can make it difficult to pull the conductors through the conduit and can also lead to overheating. When using THHN conductors, it is important to ensure the conductors are properly supported and secured. THHN conductors are typically installed in conduit or cable trays to provide physical protection and support. It is also important to avoid bending THHN conductors too sharply, as this can damage the installation. When connecting receptacles in parallel, it is important to ensure that all connections are properly made and that there are no loose wires. Loose wires can create a fire hazard and can also cause the circuit breaker to trip. It is also important to use the correct type of receptacle for the application. For example, if you are installing a receptacle in a damp location, you should use a weather-resistant receptacle. When using AFCI breakers, it is important to understand how they work and how to test them. AFCI breakers are designed to protect against arc faults, which are a common cause of electrical fires. AFCI breakers detect arc faults by monitoring the current waveform in the circuit. When an arc fault is detected, the AFCI breaker will trip, interrupting the flow of current and preventing a fire. It is important to test AFCI breakers regularly to ensure that they are functioning properly. AFCI breakers can be tested using a test button that is located in the breaker. Pressing the test button should cause the breaker to trip. If the breaker does not trip when the test button is pressed, it should be replaced. When installing electrical wiring, it is important to follow all safety precautions. Always turn off the power to the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment such as safety glasses and gloves. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician. Derating is a reduction in the allowable ampacity of a conductor due to factors such as ambient temperature, the number of conductors in a raceway, or the type of insulation. The NEC provides tables and guidelines for derating conductors in various situations. It is important to understand how derating works and how to apply it properly to ensure that your electrical wiring is safe and compliant. The ampacity of a conductor is the maximum amount of current that it can carry safely without overheating. The ampacity of a conductor is determined by its size, type of insulation, and the ambient temperature. The NEC provides tables that list the ampacities of various types of conductors. When conductors are installed in a raceway, such as EMT conduit, the ampacity of the conductors must be derated if there are more than 3 current-carrying conductors in the raceway. This is because the heat generated by the conductors can build up inside the raceway, causing the conductors to overheat. The NEC provides tables that specify the amount of derating that is required for different numbers of conductors in a raceway. For example, if there are 4 to 6 current-carrying conductors in a raceway, the ampacity of the conductors must be derated to 80% of their original ampacity. If there are 7 to 9 current-carrying conductors in a raceway, the ampacity of the conductors must be derated to 70% of their original ampacity. The NEC also requires that conductors be derated if they are installed in an area with a high ambient temperature. The ambient temperature is the temperature of the air surrounding the conductors. The NEC provides tables that specify the amount of derating that is required for different ambient temperatures. For example, if the ambient temperature is 86 degrees Fahrenheit, the ampacity of the conductors must be derated to 100% of their original ampacity. If the ambient temperature is 104 degrees Fahrenheit, the ampacity of the conductors must be derated to 82% of their original ampacity. It is important to note that derating factors are cumulative. This means that if a conductor is subject to multiple derating factors, the total derating factor is the product of the individual derating factors. For example, if a conductor is installed in a raceway with 4 current-carrying conductors and the ambient temperature is 104 degrees Fahrenheit, the total derating factor is 0.80 multiplied by 0.82, which equals 0.66. This means that the ampacity of the conductor must be derated to 66% of its original ampacity. When calculating the ampacity of a conductor, it is important to use the correct values for the conductor size, type of insulation, ambient temperature, and number of conductors in the raceway. It is also important to consult the NEC for specific requirements related to your installation. Electrical metallic tubing, or EMT, is a type of rigid metal conduit that is commonly used for electrical wiring. EMT is made of steel or aluminum and is typically galvanized to protect it from corrosion. EMT is available in a variety of sizes and is typically connected using fittings that are designed to be either screwed or clamped onto the conduit. EMT is a popular choice for electrical wiring because it is relatively inexpensive, easy to install, and provides good protection for the conductors. EMT is also non-combustible, which makes it a safe choice for use in buildings. When installing EMT, it is important to use the correct fittings and connectors to ensure that the conduit is properly grounded. EMT conduit is typically grounded through the metal raceway, which provides a low impedance path for fault current to flow back to the source. It is important to ensure that all EMT fittings and connectors are properly tightened to maintain a good electrical connection. When running conductors and EMT conduit, it is important to avoid exceeding the maximum allowable fill rate. The NEC specifies the maximum number of conductors that can be installed in a given size of conduit. Exceeding the maximum fill rate can make it difficult to pull the conductors through the conduit and can also lead to overheating. THHN wire is a type of single conductor electrical wire that is commonly used in residential, commercial, and industrial wiring. THHN stands for thermoplastic high heat nylon coated. THHN wire is insulated with a tough, heat-resistant thermoplastic material that is covered with a layer of nylon. This combination of materials provides THHN wire with excellent resistance to heat, moisture, and abrasion. THHN wire is typically used in conduit or other raceways to protect it from physical damage. THHN wire is available in a variety of sizes and colors to meet the needs of different applications. When installing THHN wire, it is important to follow all applicable codes and regulations. THHN wire is typically rated for 600 volts and can be used in dry or damp locations. However, it is not suitable for use in wet locations unless it is specifically listed for that purpose. When connecting THHN wire to devices such as receptacles and switches, it is important to use the proper terminals and connectors. The terminals and connectors should be rated for the size and type of wire being used. It is also important to make sure that the connections are tight and secure. Arc fault circuit interrupters or AFCIs are devices that are designed to protect against electrical fires caused by arc faults. Arc faults are dangerous electrical conditions that can occur when damaged or deteriorated wiring creates an unintended electrical path. These arc faults can generate high levels of heat that can ignite nearby combustible materials, leading to a fire. AFCIs work by monitoring the electrical current flowing through a circuit and detecting the unique characteristics of arc faults. When an arc fault is detected, the AFCI quickly trips the circuit, cutting off the flow of electricity and preventing a fire. AFCIs are typically installed in electrical panels and are designed to protect entire circuits. They are required by the National Electrical Code or NEC in many areas of the home, particularly in bedrooms, living rooms, and other areas where people are likely to be present. There are two main types of AFCIs: branch or combination AFCIs and outlet branch circuit AFCIs or OBC AFCIs. Branch or combination AFCIs provide protection against both series and parallel arc faults. Series arc faults occur when there is a break in a single wire, while parallel arc faults occur when there is a short circuit between two wires. The OBC AFCIs only provide protection against parallel arc faults. When choosing an AFCI, it is important to select one that is appropriate for the type of circuit being protected. It is also important to test AFCIs regularly to ensure that they are functioning properly. AFCIs can be tested using a test button that is located on the device. Pressing the test button should cause the AFCI to trip. If the AFCI does not trip when the test button is pressed, it should be replaced. Installing and maintaining AFCIs is an important step in protecting your home from electrical fires. By detecting and interrupting arc faults, AFCIs can help to prevent fires from starting in the first place. In summary, when adding receptacles in a bedroom, it is important to consider the number of conductors in the EMT conduit and derate the circuit accordingly. It is also important to use AFCI breakers to protect against arc faults and to follow all applicable codes and regulations. By following these guidelines, you can ensure that your electrical wiring is safe and compliant.